This is lesson number 2 on finite differences. We worked out linear. Now we're going to look at quadratic. I need x values. Plug them in. 10, 5, 2, 1, 2, 5, and 10. Make a table. First difference, scratch the box. 5 minus 10, negative 5. 2 minus 5, negative 3. Negative 1, 1, 3, 5. These are not the same, so it's not from a linear equation. Second difference. Negative 3 minus 5, 2. Negative 1 minus a negative 3, 2, 2, 2, 2. These are the same. It must be quadratic. It must have come from y equals ax squared plus bx plus c. Again, we're lucky enough to be given this one. So we now know y equals ax squared plus bx plus 1. I'm going to go for a second sheet of paper since I'm running out. Pick any other sets of values. How about at 1, 2? 2 equals a plus b plus 1. Bring the 1 across. 1 equals a plus b. Great. Pick another set. At negative 1, 2. 2 equals a minus b plus 1. Bring the 1 across. 1 equals a minus b. I've done it like this so I can use elimination. Add these up. 2 equals 2a. A equals 1. Use this. Plug it into either one of these above. If a is 1, 1 equals 1 plus b. B is 0. That means my equation must have been y equals a was 2, b is 0 plus 1. There is the equation that generated that data. Again, it reaffirms what we already knew. Let's do the next one. Negative 3, negative 2, negative 1, 0, 1, 2, 3. It's best to use a calculator for this so we don't make mistakes. Table. First, scratch the first box. Negative 10, negative 6, negative 2, 2, 6, 10. I'm subtracting 5 minus 15, and so on. They're not the same. They're not linear. 2 boxes gone. Negative 6 minus a negative 10 is 4. Negative 2 minus a negative 4. 4, 4, and 4. Great. Y equals ax squared plus bx plus c. Again, generous. We get this. Ax squared plus bx minus 3. Again, I got a second piece of paper. Same as before. At 1, negative 1, I get negative 1 equals a plus b minus 3. 2 equals a plus b. Pick another set of data. Negative 1, negative 1. Negative 1 equals a minus b minus 3. 2 equals a minus b, elimination. 4 equals 2a, a is 2. Plug it in. 2 equals 2 plus b, and once again b is 0. Y equals 2x squared 0b minus 3. There's my equation. One more. -3, -2, -1, 0, 1, 2, 3. I need to generate y values. I will get, if I plug them in, 32, 16, 6, 2, 4, 12, 26. First difference, -16, -10, -4, 2, 8, 14. You can work these out on your own, but hopefully you get the idea. If I do the second difference, oddly enough, it is y equals ax squared plus bx plus c. There's my c. Y equals ax squared plus bx plus 2. At 1, 4, 4 equals a plus b plus 2, which is going to give me 2a equals a plus b. Add another set of data, -1, 6. 6 equals a minus b plus 2. 4 equals a minus b. 6 equals 2a. A is 3. Plug it in. 2 equals 3 plus b. B is -1. That means y equals, a was 3, b was -1, and c was 2. There's the data. There's the equation. Now, we are looking for patterns. If you look at your difference, is 6, a is 3. Difference is 4, a is 2. Difference is 2, a is, whoops, was 1 over here. Sorry about that. In each case, I divided each of the differences by 2, which is what the exponent is. If I flip the sheet over to the last lesson, in the first case, the difference was 3, a was 3. The difference is -1, a was 1. The exponent, careless on all of these, the exponent was 1. Let's do one more from the third sheet. All right. First difference, scratch that out. -7, -3, 1, 5, 9, 13. Lot linear. Scratch 2 boxes out. -3 minus a negative is 4. 4, 4, 4, 4. Great. Now, the common difference is 4. That means a is the difference divided by the exponent. Now, you will find next year that this is not completely correct, but it's good enough. 4 divided by 2 is 2. C often is given. In this case, C is 1. We now have y equals 2x squared plus bx plus 1. Pick a set of data. 1, 6. 6 equals 2 plus b plus 1. 6 equals 3 plus b. b must be 3. Y equals 2x squared plus 3x plus 1 is the equation that generated that data. That leaves you 2 more to do. Thank you.